How are you, viewers? In the next couple of videos, we will only be looking at questions that deal with the mole concept. And to kickstart this, we will be looking at the 2020 Science Paper 2. And in this particular case, we will be looking at question B3 of the Science Paper 2 2020 paper. And question B3 reads, in an experiment to prepare a salt, a learner reacted 3 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 moles per cubic decimeters. In an experiment to prepare a salt, a learner reacted 3.0 grams of magnesium oxide with 40.0 cubic centimeters of dilute nitric acid of concentration 2.0 moles per cubic decimeters. A. Write a balanced chemical equation for the reaction. B. Calculate the number of moles of 1. Magnesium oxide, 2. Dilute nitric acid. C. Determine the limiting reagent. All right, let's start. Okay, so we are told to write a balanced chemical equation. Remember, we will take note of the following. We are preparing a salt, okay, and we will be using magnesium oxide. Now we need to classify the group of compound from which magnesium oxide belongs to. Now, magnesium oxide belongs to compounds called bases. Okay, now just as a reminder, a base is a metal oxide or hydroxide including ammonia. Okay, a metal oxide or hydroxide including ammonia is a base. All right, so magnesium oxide, a base, is reacted with dilute nitric acid. So this type of reaction involves the reaction between a base and an acid, and there are only 2 products. When a base reacts with an acid, we only expect 2 products, that is a salt and water. So let's start. So we've got magnesium oxide, which is MgO. So why MgO? Magnesium has a valency of 2 and oxygen has a valency of 2. So the valencies will actually cancel out because 2 goes into 2, therefore giving us 1 magnesium reacting with 1 oxygen. Then it will be plus. So magnesium oxide plus its nitric acid. Nitric acid is HNO3. This is nitric acid. Okay, then these are our 2 reactants. So the product is definitely going to be magnesium nitrate plus water. So we've just done the first part of the question, which is just writing the equation. Now we need to balance this equation. Now we are going to balance it by inspection. So we will now be looking at the number of atoms of each element on the product side and also on the reactant side. They should be equal. So what we should always look at when we are balancing a chemical equation is that we should always balance hydrogen and oxygen last. So since we are balancing by inspection, on the reactant side we have 1 magnesium and on the product side we have 1 magnesium. So magnesium is balanced. Then we go to nitrogen. Nitrogen on the reactant side, we have one nitrogen, while on the product side, we have two nitrogens. Okay, we have two nitrogens. So because we have one nitrogen on the reactant side, we need to multiply the nitric acid by 2 so that we have two nitrogen. So you come here and write a 2 in front of nitric acid so that the 2 multiplies with the 1 nitrogen, giving us 2 nitrogens. So that will be our way of balancing the nitrogen. So the nitrogen there has been balanced. We move on to hydrogen. Hydrogen on the reactant side, we have 2. And the 2 is coming from 2 in front of the nitric acid. We have hydrogen there. And also on the product side, we have hydrogen in the water, and it is 2. So 2 hydrogens on the reactants, 2 hydrogens on the products. We go to oxygen. Oxygen, the magnesium oxide has got 1 oxygen. The nitric acid has got 3 times the 2 in front there gives us 6. So 6 plus 1 gives us 7. So on the reactant side, we have 7 oxygens, while on the product side, we have 3 times the 2, which is outside the bracket there, which is 6 plus 1 oxygen on the water. This gives us 7. So this reaction, we can safely say that the reaction is balanced. So for doing that, we actually get our 2 marks. So we get our 2 marks. Then we now come to part B. Part B is saying calculate the number of moles of magnesium oxide. The number of moles of magnesium oxide. So for us to calculate the number of moles of magnesium oxide, we will use the formula because we have been given, in the formula, we've been given the mass of magnesium oxide, which is 3.0 grams. So since we have the mass of magnesium oxide, we are going to use the formula number of moles N is equal to the physical mass M over the molar mass. So the physical mass divided by the molar mass. Now we have the physical mass, which is 3 grams. Do we have the molar mass? We can calculate. So what we've been given is we've been given magnesium oxide, and we will do this. So we have 1 atom of oxygen times 16, which is the relative atomic mass of oxygen. So this will give us 16. Then we go to magnesium. Magnesium, we only have 1 atom times 24, which will give us 24. So this gives us 24. So 16 now plus 24 will give us 40 grams per mole. 40 grams per mole. So it means magnesium oxide weighs, 1 mole of magnesium oxide weighs 40 grams. So we can now substitute the molar mass into the formula. So we have N is equal to the physical mass, which is 3 divided by 40. So 3 divided by 40 gives us 0.075 moles. So we will now say the number of moles is equal to 0.07, okay, 0.075. So this is the number of moles. Now we find where to write our final answer. So our final answer now, we are now going to say that the number of moles, okay, therefore we can say, therefore Therefore, N is equal to 0.075 moles. So this is our final answer. So there we have it. We have just calculated the number of moles of magnesium oxide. We move on to B. B is the number of moles of dilute nitric acid. The number of moles of dilute nitric acid. But what have they told us about nitric acid? They have given us the volume of nitric acid, which is 40.0 cubic centimeters of nitric acid. And we've been given the concentration of nitric acid. So what are we going to use? The formula we're going to use comes from the formula for concentration. We know that concentration is equal to number of moles over volume. But we are looking for the number of moles. Therefore, we can say or number of moles is equal to concentration times volume. Now, take note, the volume should always be in cubic decimeters. The volume should always be in cubic decimeters. So if we convert 40 cubic centimeters, so we know that 1 cubic decimeter is equal to 1000 cubic centimeters. So what we do is we'll put x cubic decimeters will give us 40. Okay, 40 what? 40 cubic centimeters. Now, if we cross multiply, here we cross multiply, what we are going to have is that x is equal to 0.04. We'll have 0.04. So we have volume is equal to 0.04 cubic decimeters. Okay, now we can substitute this into the formula. So we now have number of moles is equal to concentration, it's 2 times the volume 0.04. So 2 times 0.04 gives us 0.08 moles. So this will give us 0.08 moles. So this is our final answer. So we are going to have 0.08 moles of nitric acid. So we're going to have 0.08 moles of nitric acid. Okay, we go to C. We go to part C. Part C is saying determine the limiting reagent. Determine the limiting reagent. Now we need to understand what a limiting reagent is. Now a limiting reagent is the reactant that will finish, okay, that will finish first before the other reactants finish. So we are basically looking at which reactant have they given us less than what is required. So we are looking for a reactant that is less than the required. So we only have 2 reactants, and these 2 reactants are, magnesium oxide magnesium oxide, and we have so magnesium oxide. We will now just deal with the relationship. So it's magnesium oxide to nitric acid. Magnesium oxide to nitric acid. Magnesium oxide to nitric acid. That's the relationship we are looking at. Now, we go back to the balanced chemical equation. Now, 1 mole of magnesium is reacting with 2 moles of nitric acid. So we need to put this relationship down here. Okay? So we know that 1 mole of magnesium oxide is reacting with 2 moles of nitric acid. But we have also determined the number of moles of each and every reactant that has been given to us. So for magnesium oxide, we have been given 0.07 moles. This one here, 0.07 moles. And for nitric acid, we have been given 0.08 moles. So from these two, we can choose any one of them. We can choose any one of them so that we find for the other reactants what it is requiring. So we will get for magnesium oxide. We will get for magnesium oxide. You can even get for nitric acid. So for magnesium oxide, we are told that it is 0.075 moles. Okay. Now this under nitric acid, we are going to put X. So by doing this, we just want to find out how many, if we have 0.075 moles of magnesium oxide, what number of moles of nitric acid is needed to react with 0.075. Okay, then compare that to what has been given under nitric acid. So we're just going to cross multiply. Okay, we're going to cross multiply. Now if we cross multiply that, what we are going to have is 1 times x is equal to 2 times 0.075. Okay, so and what this is going to give us, x is equal to 2 times 0.075 gives us 0.15. So this is equal to 0.15 moles. Moles of what? This is of nitric. This is of nitric acid. So this is of nitric acid. So this is of nitric acid. So now, because this is for nitric acid, the 0.15. So it means that 0.075 moles of magnesium oxide will react with 0.15 moles of nitric acid. But what have we been given for nitric acid? What we've been given is 0.08. Now, what has been given? So this is what is needed. So the 0.015 is needed. This is needed. Okay, this is what is needed. And the 0.08 is moles is what we've been given. So we've been given 0.08 moles, but what is actually needed is 0.15. So what is needed is more than what we are given. Now, if what we've been given is, what is needed is more than what we've been given, it means that this will finish before the reaction ends. So hence, this is the limiting reagent. Therefore, we are going to say that nitric acid, because what we've been given is less than what is needed, nitric acid is the limiting reagent. So the limiting reagent here, the limiting reagent is nitric acid. So nitric acid is the limiting reagent. So nitric acid is the limiting reagent. So there we are. So nitric acid is the limiting reagent. However, if we found that what is needed was less than what was given, then it means the other reactant is the limiting reagent. Thank you very much for watching this video. If you like the video, don't forget to like the video, and also if you are new to this channel, don't forget to subscribe. See you next time.